All right, this is section 2.1. This is part A. So we're asked here to determine the intervals in which the function is increasing, decreasing, and constant. First thing I notice right here is this minimum point here at x equals -1. And obviously the function here is increasing as values get larger than -1, and they were decreasing for values that were less than -1 way out here at negative infinity. So the hard part about this is a lot of these answers are very, very, similar. But I'm kind of zeroing in on -1. All right, everything starts out increasing. Now I know it starts increasing here at -1, and as x values get larger. The only way I see -1 is letter D. Let's see if letter D is right. So from -1 all the way out to infinity, this thing is increasing and decreasing. It started decreasing here at negative infinity and came all the way down, stopped decreasing at -1. So letter D is my choice. I say the hard part here is that a lot of these, they just look alike. So it's a matter of determining, which one is saying the right thing. So I see increasing, decreasing, and constant. Well, it's constant between here and -4. And it stops being constant at +4. So as I scan these, I only see letter A and letter D constant from -4 to +4. So already I know it can't be B or C. Now, increasing. Well, it starts increasing at 4, and it keeps increasing as values get larger all the way out to infinity. So I like that, but letter in D says the same thing as letter A does, increasing from 4 to infinity. So let's take a better look at this. Decreasing would start here at negative infinity, way out here, and stop decreasing at x equals -4. So I got it right here. That says just the opposite. So process of elimination, we got letter A. Gotta be careful. A lot of them look alike. So you kind of zero in on something that's fairly obvious to you and find the right match. D, I've already marked this, I shouldn't have, but here again we've got increasing, decreasing, and constant. You probably can't see it here because it's right over the x-axis, but constant between 0 and 2. Alright, so here again I see between 0 and 2 and 0 and 2. B and C didn't have that, but I already told you it's D. Now why is it D? Alright, increasing. Decreasing, we got a constant between 0 and 2. Increasing between -3 and 0. Alright, this guy's got between -5 and 3. No, from -3 to 0, it's increasing. So that's why I knew it was letter D and it wasn't letter A, even though A and D had the right constant interval. Alright, so we flip gears now, looking for domain and range. Domain is the set of x values used in the function, and the range is your y values. So closed dot here, closed dot there, between -3 and 0 is my domain, between -3 and 0. So I'm looking at number 4 and -3 and 0, and my range is from -2, my y values, all the way up to +2, and there it is. Letter A, that's pretty straightforward. That wasn't a bad one. Alright, so my range starts at 0 here, including 0, and goes all the way out to infinity, my domain. Alright, so my range is from -3, and here again, this is going all the way up and up and up and all the way out to infinity. So number 5, I've got it domain between 0 and infinity, from 0 all the way out to infinity, and my range from -3 all the way up to infinity. Letter A, number 5, letter A. That wasn't so bad. Domain set of x values, your range is the set of y values that are used. notice number 6, I've already circled the answer. But looking at this, why is it letter A? Well, if this were to stop, all right, usually you're used to seeing arrows here, all right, but the software doesn't do that. If this was stopping at -5, you would have a dot here, and you would have a, well, actually, you're looking for the domain, so that's not even a kid. I'm looking, the domain is, this is going all the way out. Let me see if I can erase this. Yeah, okay. This is going all the way out to infinity, and this is going all the way out to infinity. All right, domain from negative infinity all the way to positive infinity. And the range is from 0, and it stops here at 4. From 0 to 4 is your range. That's why it's letter A. Number 7, the domain from 0 to 12. All right, from 0 to 12. Now notice, this one is from 1 to 6 and from 1 to 6. We know it's not neither one of these. So 0 to 12, but notice you've got a dot here at 0, 1 and a dot here at 12, 1. All right, so both of these points are included. The 0 is included and the 12. That's why you've got the brackets. All right, if you had open circle here and an open circle there, then it would have been letter C. 0 and 12 would not be included. The closed dot means you include them, which means relates to our bracket, since both those values are included. 0 and x equal 12 is included. Number 7, letter A. All right, we're looking for maximums and minimums. Number 8. And let's see, I got a minimum point here. All right, now the minimum point, this is number 8. The minimum point is a y value, and it happens at an x value. So here we got it. The minimum point here is my y value is y equals -2. So I have a minimum of at y equal -2, a minimum at -2, a minimum at -2. All right. And these guys are talking about maximums, but there is no maximum here. There is no relative maximum. There's an absolute maximum of infinity, but there is no relative. So I know it can't be A, nor can it be B. Now, both of these say, okay, I got a, well, I take that back. D says I got a maximum at -2. Well, that's far from being a maximum. This is a low point. This is a minimum. All right, so number 8, this is why I'm answering letter C. I have a minimum at -2, not a maximum. All right. So my minimum value is -2. It happens where x is equal to 3. Now the rest of it is right because it's increasing from x equal 3 all the way out to infinity, and it's decreasing from negative infinity down to x equals 3. So letter C. Number 9. And what have I got here? Well, I got a maximum here and a minimum there. All right, so I have a maximum of negative 18. All right, I'm sorry, positive 18. A maximum, my y value here is y equals 18. So I'm looking for a maximum at 18. Well, I got a maximum here of 18. I got a maximum here at 18. So pretty sure it's not B or D. Now, what's the difference here? This one tells me there's no relative. It can't be that. And I don't have a maximum at y equal -14. So A and C are in the running. Now, what's the difference between letter A and letter C for number 9? C tells me here that I've got a maximum of 0 when x equals 0. Well, that's nothing going on here. I mean, that's not a maximum at all. Maximum is the high point and the minimum is the low point. There's nothing going on there at x equals 0. So by process of elimination, all right. Now here I got a relative minimum, my y value -14. It happens at x equals 2. And the rest of it obviously is going to be, I mean, I've already discounted A, B, and D. There's no choice but to be letter C. The rest of it's going to be correct. Here I'm saying is kind of zero in on the minimums, on the maximums, and kind of look at how he's given to you. It's a process of elimination. Everything is correct. Usually you can discount a couple right off the top. And number 10, let's see, I've got a minimum point here and a maximum point there. So I have a minimum, all right, at y equals 1.547. Oh, here, maximum. Now, that says maximum. Let's see. I'm looking for a relative minimum. Well, right here, relative minimum of that, it happens at x equals 3 point. There it is. All right, there's my x value. There's the minimum point. Then I've got a maximum here at y equal 3.08. There it is, maximum at 3.008, and it happens when your x value is 0.159. Letter C all day long. Yeah, you gotta read through it and make sure every part. Usually there's 2 that you can discount, and then there's 2 that differ slightly. All right, so remember, minimums are low points, maximums are high points. All right. That's part 1. Part 2, piecewise functions. So, what he's telling me is piecewise functions. If my x value is less than or equal to -1, use this function. And if your x value is bigger than -1, use this function. Well, in fact, he gives me find f of -5. Now, the idea is, where does -5 fit in this range? Is -5 less than or equal to -1? Well, sure it is. All right, -5 is not bigger than -1. It's less than or equal to. So I'm utilizing that top function. All right, so in place of x, I'm going to substitute -5. 3 times a -5, -15, letter C. Where does 0 fit in? All right, 0 is less than 4. It's not bigger than or equal to. So if you have a value, an input that's less than 4, my x value here, all right, I'm utilizing the top function. All right, so in place of x, I'm going to substitute in 0. 0 subtract 3, well, that's -3. And letter B. All right, number 3. Where does 7 fit in? Which one of these ranges does 7 fit in? Is it less than 0? No. Is it between 0 and 6? No. Is 7 greater than or equal to 6? Yes, it is. So use this. All right. So in place of x, I'm going to substitute 7. That's really straightforward. Number 3, letter B. Where does 4 fit in here? Well, it's not less than 1. 4 is between 4 and 8 inclusive. All right, 4 is not. 4 is less than, it's equal to 4. All right, so I'm utilizing this. In place of x, I'm putting in 4. 4 4s are 16. Letter B. 4B, letter 16. Number 5, I've got a -9. Where does -9 fit in? Well, -9 is less than 9. All right, so I got to use this function. So in place of x, I'm going to substitute -9. 6 times a -9 plus 1 more, -54 plus 1 would be a -53. And number 5, I've got letter D. Now, from here on in, I got to do a separate video because I want to incorporate the TI-84 calculator. So I'll see you in the next video.